So in last class we have discussed about how to find out the average rainfall in a catchment area, right? And we have seen নাম লেখা আছে এগুলোর মধ্যে কিছু গ্যাপ না গ্র্যাব কি বলছো গ্রাফ আচ্ছা কিসের মাস কার্ভ ডাবল মাস কার্ভ কোনটা রিপিট কোনটা ডাবল মাস কার্ভ না মাস কার্ভ mass curve. The mass curve is nothing but the representation of precipitation, total precipitation or cumulative precipitation with respect to the time, right? So if you find out the cumulative rainfall for a certain time period, right, in a certain time interval, then if you plot the cumulative rainfall in a graph, that will be called as mass curve. Simple, nothing but this one, right? So if you go and see the reading in the field, suppose we are having that non-recording rain gauge over there, over the water resource lab, right? So if you go there during the precipitation and suppose we are having 1 hour of storm, suppose, and in certain interval like in 10 minute, in regular interval of 10 minutes you are going there and finding what is the total rainfall occurring. So ultimately you are not making the flask empty. That means what? You are getting the cumulative rainfall directly. Okay. So if you are finding out that cumulative rainfall in a particular certain time period, suppose in 10 minutes of time period, then if you plot with respect to the 10 minutes what is the precipitation, in 20 minutes what is the total amount of precipitation, in 30 minutes what is the total amount of precipitation, if you connect all the points with a smooth line, that will be called as a mass curve. আর কিছু ঠিক আছে. So in the last class we have discussed that how we can find out the average precipitation in a catchment area, as because there will be several number of rain gauge stations over there, and for different rain gauge station different values of rainfall data you will get, right? So for a particular day or for a particular month or whatever it is, what will be the total rainfall or average rainfall of that total area? How we can find out that one? To find out that one we are having those 3 methods, and we have seen what are the methods. We have seen the formula, right? For the first one, that is arithmetic mean method, we are having this formula where nothing but we need to sum up all the precipitation values and divide with the number of rain gauge station over the catchment area, and we can get what is the average precipitation on that area, right? Similarly, if we give some weightage with respect to the area covered by any rain gauge station, then we can go for this one, that is called the Thiesen's polygon method, where we generally connect all the rain gauge stations with a straight line and we find out the perpendicular bisectors, and we generally extend those perpendicular bisectors to a certain extent so that they will meet at a certain point. Then we will have some sort of polygons, right? Those polygons will be indicating the area coverage for a particular rain gauge station. Now what we have to do? We have to simply give that weightage to that precipitation data, sum up all the values and divide it by the total areas, because we are multiplying the area, right? So divided by the total area we will get the average precipitation values. In simplifying that equation, you will get this sort of equation where nothing but all the precipitation value will be multiplied with a factor, that is the area covered by the rain gauge station divided by the total area, and if you multiply that factor with each and every precipitation, and if you sum up the value, you will get the average precipitation value, right? And we have seen this one as well, where we need to find out some sort of isohedge. And what is isohedge? I have already told you that it is nothing but an imaginary line connecting all the points which are having same amount of rainfall, right? So after getting all the data where the precipitations data of each and every stations, we can find out those points where we are having, suppose 30 precipitation is there, where 40 precipitation is there, where 50 precipitation is there, and so on, right? And next is what? Next we need to find out the area between two isohedge line, two area between isohedge lines. So if the isohedge line number is n, then the area number will be n minus 1, right? And we have to multiply that area with the precipitation difference or average precipitation between the isohedge line, right? So for the first case, if the precipitation of isohedge is P1, precipitation of isohedge is P2, then the average precipitation between those isohedge line will be P1 divided by P1 plus P2 divided by 2, and that will be multiplied by the area between those two isohedge line, and simplifying we are having this formula. Clear? Those are the formula. I will show you the formula during this class, but there will be some examples which you have to solve right now. Yes, yes, there will be some examples. I will be showing you the example. You need to solve the example and give me the values of precipitation. Any formula you need, I will provide you the formula, right? First example is this one. You need not to write the example as because this is taken from your textbook, right? You need not to write the example, just see the data, solve it. Here a map is given, a map of catchment area is given, and the positions of various rain gauge stations like where is 1, 2, 3, 4, 5, 6 number of rain gauge stations are there, right? Yeah. Some rain gauge stations are inside the catchment area and some are the neighboring stations, right? Neighboring stations to the catchment area. Clear? And the values of the rainfall recorded on various rain gauge stations are given like this with respect to various rain gauge stations, and the Thiesen's polygon area covered by the rain gauge stations are given in kilometer square, are given with respect to the rain gauge stations 1, 2, 3, 4 and 5. First of all, you need to find out the value of average rainfall by arithmetic mean method, then Thiesen's polygon method. হ্যাঁ করো কত 123.166. Anyone having 123.166, give the unit, na? What will be the unit? Unit is given in millimeter, it is given, right? All the precipitation are given in millimeter, so provide the unit. 123.166, 123.33. The back bench, anyone have solved? Anyone has solved this arithmetic mean method? Directly calculator করো না, খাতায় লেখার তো কি আছে? Now anyone having different value rather than 123.166, 33. Anyone having different value than 123.33 millimeter? Anyone? Those who have solved already, raise your hand. Those who have already solved this সেশনে করবে না তোমরা? আচ্ছা, anyone with a different value? This confusion will occur, obviously. This confusion will occur, and I will say this is not correct. Clear? I will say this is not correct. Then what is the error? What is the confusion you are having? See, look thoroughly. That will not be, maybe that will be the answer, but the method you are doing, that is wrong. Na, ota alada chilo. That is where missing data is there, right? If you need to find out the missing data, then you have to find out the 10% difference in normal precipitation in that case as well. This is not normal precipitation. This is precipitation for 1 year. What is the problem? Bolo. Yeah. Yes. ওটাই এরর। বলো কি হচ্ছে, তাহলে প্রবলেমটা কি হচ্ছে, সলিউশন কি হবে? What will be the solution? Whenever you are finding out the average rainfall by simply arithmetic mean method, you need not to consider the data from the outside of the catchment area, right? Whenever you are finding out the average rainfall by arithmetic mean method, you need not to consider the data outside the catchment. Here, so here only three rain gauge stations are there which are inside the catchment. You need to consider only those three values and divide with 3. When 127 it is. Any confusion regarding this one? Yes. We will consider the outside data whenever you are finding out the polygon or isohedges. So if you are doing the Thiesen's polygon method, or if we are doing the isohedral method, then only we have to consider the outside data so that we can find out the isohedges properly or Thiesen's polygons properly, covering all the catchment area. Bolo. Arithmetic mean method, it is nothing but the values of all the rainfall you are finding in the catchment area divided by the number of stations. So obviously, if you are finding out the average rainfall for a particular catchment area, we will consider the insider data only, as because those are not the insider data, right? Those are the outsider data. To find out the polygon, to find out the isohedges, obviously you need to cover whole area, right? Whole catchment area. Now for that case, if you consider only the inside catchment area, inside rain gauge stations, then you cannot complete you cannot get those polygons will be completely covering the catchment, or maybe you will not get those isohedges which will be covering the total catchment area. For those cases only we need to consider the outside data. Other than that, insider data will be enough. What will be the next? That is finding out the average rainfall by Thiesen's polygon method. If you need, this is your formula. আচ্ছা এটা ফর্মুলা দিয়ে দিলে আবার ডেটা গুলো পাওয়া যাবে না ডেটা রিটেন datas are written you can write down the equation and I will show you the data summation of pi ai by a where I will vary from 1 to n হয়েছে ইকুয়েশন লেখা ওকে this is your question pi summation of pi ai by a this is a factor you can write in this way as well, right? But we are finding out a factor, so it is better to write like this one, where I will vary from 1 to n. This is your formula. আচ্ছা আমি জানি না আমার I don't know the answer. কত এসছে আচ্ছা করো yes why as because we need to find out the polygons where polygons will be covering the total catchment area. If you consider the insider catchment insider rainbow stations only, you cannot get the polygons which will be covering the outsides of the catchment area, so you have to go beyond them, right? আর কেউ anyone else with the answer? অবশ্যই I've already told you in the when I was describing the method itself, you can see some outsider data are given in Thesian's polygon and as well as isoheds. Here also you can see some data are there outside the catchment area. Here as well some data are outside the catchment area. Other than that you cannot cover a whole area. It is not possible to cover whole area. Anyone else with the answer? কত তোমার কত এসেছিল 121.49 ওকে করবে না করেছো কত ঠিক আছে মেবি ওটাও ঠিক হতে পারে দেখা যাক should we go for the solution or someone will try? Okay, 1 second. Okay, $121.37 again. Okay, now can we move to the solution? Okay, now for those cases it will be better to prepare one table, right? You can solve it in numerical way as well. Other than that you can find out or you can draw a table like this one if it is visible from the last bench as well, if you are interested only. So here you can see stations numbers are given or name of the stations are provided. In this second column you are having Thesian's polygon area in kilometer square, right? In the third column we are finding out the factor, weighted factor, that is nothing but I've already told you the formula is nothing but summation of pi ai by a where I will vary from 1 to n. Now this is the weighted factor. This is the weighted factor, and it will vary. For number 1 station, it will be A1 by A. For number 2 station, it will be A2 by A, and so on, right? So ultimately you can see, we find out the total area of the catchment, and that will indicate the total area of the catchment, summing up all the areas of the polygon areas, right? Summing up all the polygon areas, you are covering the total catchment area. That is the funda, right? Yes or not? Summing up all the polygons, you are covering the total catchment area. So if you sum up all the values, you will get the total area, catchment area. Now this is A, this is A1, A2, A3, and so on. So if you divide the column number 2 with 3600, you will get AI by A itself. AI by A itself, right? Okay. Now we are having the precipitation values, that is in millimeter, for all the station. Those are the given data. These are also given data, right? Now what is the formula? Formula is nothing but Pi multiplied by AI by A. Now this is AI by A, this is Pi. Simply multiply column number 3 and column number 4, you will get the Pi multiplied by AI by A. And if you sum up the total values, summation of Pi AI by A, so if you sum up all the values, you will get the average precipitation, which is equals to 121.5 millimeter. তোমার এসেছিল বোধহয় না, না কত 125 এসেছিল, 121 point something এসেছিল, যাদের অলমোস্ট কাছাকাছি আছে, ঠিক আছে। Is it clear? You can do it in numeric or arithmetic way as well. There is no boundary, there is no boundary. But if arbitrary sections are given or arbitrary catchment area shape is given, then obviously the area will be provided to you, as because the area of arbitrary sections or arbitrary shapes can be find out by calorimeter only, and in example obviously it will not possible to find out the areas of those arbitrary shapes. Clear? So obviously the area will be provided if those type of shapes are given to you. Similarly, we are having another example. This is also one example where the area should be given. Other than that, the area cannot be find out. But I will not go to this example, as because this is similar to the last example where the area need to be known. But here we are having a different sort of example, which is again from your textbook. Here various coordinates are given, and we are having this sort of catchment area, and you can see this catchment area is not having an arbitrary shape. It is a common shape. Clear? Simply triangle or rectangles. So obviously for those cases you need to find out the area. Clear? Now what is given over this example? For catchment boundary, corners are given, and with respect to corners, various coordinates of the corners are given. So if this is 0 0, this is 120 0, this is 120 80, and so on. So if you plot all the points with respect to the coordinates, you will get this sort of catchment area, and another thing is given, that is the coordinates and rainfall values of rain gauge stations. So rain gauge station number 1, 2, 3 and 4 pole number stations are there, and coordinates of rain gauge stations are given. Clear? With the rainfall values of the rain gauge stations. Plotting the rain gauge stations, you will get this P, Q, R, S. Now they have said, suppose they are saying to find out the average rainfall or average precipitation over the catchment area by Thiesen's polygon method. Now here you can see we are not having any sort of neighboring stations. You can extend the perpendicular bisectors and eventually it will go beyond your catchment area and then you will stop. So what is the first process? What is the first process or first step to find out the Thiesen's polygon? To connect all the rain gauge stations with a straight line. So we have connected all the stations with the straight line, and even S to Q is connected, but not P to R is connected, as because they will have a same center point, right? So from that, if you draw a bisectors, it will cross the center of the PQ and RS. So sorry, PR and SQ. So it will cross through the midsection of that joining line. Here, so we have connected all the lines, straight lines, and we are finding out the perpendicular bisector of SP. We are finding out perpendicular bisectors of PQ, QR, and RS or SR. So if you extend the perpendicular bisectors, and if you extend the perpendicular bisectors, it will provide the Thiesen's polygon for P, Thiesen's polygon for Q, Thiesen's polygon for R, and Thiesen's polygon for S. So for polygon of P will be A, I, O, whatever it is, 3 or something. It is not I, it is 1. Okay. So A, 1, O, 3. This will be the polygon for P. 1, O, 2, B. This will be polygon for Q. D, O, 2, C. This will be polygon for R, and this one will be D, O, 3, E. Now, as because this is having a common shape, right? This is rectangle. This is also rectangle, and you can split it in two different shapes. Like if you plot or if you elongate a line in this direction, you will get a triangle and you will get a rectangle, right? So eventually you can find out what is the area of the triangle, what is the area of the rectangle. So what will be the total area of the polygon covering that S or R, right? So if these sort of common shapes are given, for those cases you need to find out the area. There the area will not be given directly. Here this is rectangle, this is rectangle, this is rectangle plus triangle, this is rectangle plus triangle. So areas are calculated in this case. Other than that, same example. Areas are calculated, total area you can find, AI by A, AI by A, and all. These are the recorded rainfall, and this will be PI multiplied by AI by A, and summing up you will get the average rainfall. Any confusion? Any confusion regarding these two examples? Okay. Now another example is there, that is the example of isohedral method, where isoheads are given to you, map is given to you, but as because those are arbitrary sections, catchment area is also arbitrary, isohead lines are also arbitrary, those are not straight lines, right? Those area are given. Now if areas are given, it is easy. Simply put in the formula, you get the value, right? Simply put the values, you will get the total area, and the formula is same. Bolo? For the isoheads, what is the formula? Isohedral method. Okay. So it will be easier if the area are given. But if this sort of examples or questions arise in your examination. Hello, কোনো question? Any question regarding this class?